Note, A intersection A bar is equal to empty set. A union A bar is equal to sample space S. If A and B are mutually exclusive events, then P of A union B is equal to P of A plus P of B. Probability of union of mutually exclusive events is equal to sigma probability of events. Addition theorem of probability. If first one, if A and B are any two events, then P of A union B is equal to P of A plus P of B minus P of A intersection B. Second one, if A, B and C are three events, then P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus B intersection C minus A intersection C plus P of A intersection B intersection C. Exercise 8.4. Sum number 1. If P of A is equal to 2 by 3, P of B is equal to 2 by 5, P of A union B is equal to 1 by 3. Then find P of A intersection B. P of A union B, we know the formula. P of A plus P of B minus P of A intersection B. Here we substitute the values given. We don't know this, we have to find this. So minus P of A intersection B will become plus P of A intersection B. And these values will be as it is. Bring this positive value this side, it will become negative. Take the LCM for the denominators. We get the LCM as 15. So denominator we write 15 and 3 into 5 is 15. So multiply by 5 in the numerator and denominator, we get 5 2s are 10 here. The same way multiply by 3. So we get 2 3s are 6. Here also in the same way we multiply by 5. So we get 1 5 is 5. Add both, it is 16. 16 minus 5 is 11. 11 by 15. Question number 2. A and B are two events such that P of A is equal to 0.42, P of B is equal to 0.48 and P of A intersection B is equal to 0.16. Find first subdivision probability of not getting A, P of not A. Second subdivision probability of not B. Third subdivision probability of A or B. First subdivision probability of not A, that is P of A dash. Already we have come across this formula. P of A dash is equal to 1 minus P of A. So we write 1 minus P of A value is given 0.42. We have written here. When you subtract this 1.00 minus 0.42, we get 0.58. So this is the answer. Second subdivision probability of not B, that is P of B dash, is equal to 1 minus P of B. 1 minus 0.48 is equal to 0.52. Third subdivision probability of A or B, that is probability of A union B we have to find. Or means union. P of A union B is P of A plus P of B minus P of A intersection B. We substitute all the values, we know everything. Adding both, we get 0.90 minus 0.16. We get 0.74. Sum number 3. If A and B are two mutually exclusive events of a random experiment and probability of not A is 0.45, probability of A union B is equal to 0.65, then find P of B. Sum number 3. Given A and B are mutually exclusive events, P of A intersection B is equal to 0. That is also probability of not A is equal to 0.45. It is given. That means P of A bar or A dash, both are same. P of A bar is equal to 0.45. We know the formula. P of A bar is equal to 1 minus P of A. So we write this 1 minus, we take this P of A this side, it becomes positive. This positive value will become negative. So 1 minus 0.45 is 0.55 is equal to P of A. P of A union B is equal to P of A plus P of B, because here A and B are mutually exclusive. Since they are mutually exclusive, P of A intersection B is equal to 0. This we have already given here. So here the intersection value is 0. So we write the formula like this. So from here we have to find P of B. Keep P of B as it is. Bring this P of A this side. That means P P of B is equal to P of A union B minus P of A. We know the value, we substitute. We have written this also. When you subtract both, we get 0.10. P of B is equal to 0.10. Question number 4. The probability that at least one of A and B occur is 0.6 if A and B occur simultaneously with probability 0.2, then find P of A bar plus P of B bar. Sum number 4. Given P of A union B is equal to 0.6, P of A intersection B is 0.2. Therefore, P of A union B we find first, because it is given, values are given, we substitute. So, we write the formula P of A plus P of B minus P of A intersection B. Direct value is written, this we don't know, we have to find. So, we write the value, bring this minus 0.2 this side, it will become plus. So, P of A plus P of B is equal to 0.6 plus 0.2 is 0.8. In the question they have asked P of A bar plus P of B bar. We already know P of A bar is equal to 1 minus P of A. P of B bar is 1 minus P of B. Add both, 1 plus 1 is 2. Take this minus commonly outside. So, P of A plus P of B. We write this in the bracket. 2 minus, the value for this is already we have found 0.8. So, it is 0.8. 2 minus 0.8 is 1.2. So, P of A bar plus P of B bar is equal to 1.2. Sum number 5. The probability of happening of an event A is 0.5 and that of B is 0.3. If A and B are mutually exclusive events, then find the probability that neither A nor B happen. Solution. Given P of A is equal to 0.5, P of B is equal to 0.3, P of A intersection B is 0. Probability of neither A nor B, that means probability of A bar intersection B bar, but this is nothing but probability of A union B the whole bar. We can write P of A bar intersection B bar as P of A union B the whole bar, but P of A union B the whole bar is nothing but 1 minus P of A union B, as we write P of A bar is equal to 1 minus P of A. Likewise, we can write this also as 1 minus P of A union B. 1 minus A union B formula is P of A plus P of B minus P of A intersection B. That is 1 minus, the value for this is 0.8, that is equal to 0.2, subtracting both. Here P of A union B we have to find separately. P of A union B is equal to P of A plus P of B. So, we write both values and substitute, we add both and get 0.8. Here A and B are mutually exclusive events. Since they are mutually exclusive, A intersection B is 0. So, A union B is 0.8. So, we have substituted 0.8 and we get the answer 0.2. Sum number 6. 2 dice are rolled once. Find the probability of getting an even number on the first die or a total of face sum 8. Solution. Sample space we write, when 2 dice are rolled, sample space is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6 and so on. We write up to 6, 6. N of S is equal to 36. We get 36 elements. Let A denote the probability of getting even number on the first die. So, even number on the first die. This die, this is the first die. This denotes second die. So, we get even in the first die means we have to write this row fully. Then here also fully. Here also we write. Here we select these 3 rows because there is even number in the first die. First die there is even number. So, we get all these 3 rows. So, we have written as it is. So, total number of elements are 18. P of A is equal to N of A by N of S. 18 by 36. Let B denote the probability sum as 8. B is equal to their sum as 8. That means when you add two elements, we have to get the sum as 8. Here we cannot get. We get at this place. That is 2 plus 5 is 7 only. We need 8. So we select this. 2 plus 6 is 8. The same way, 3 plus 5. 3 plus 5 is 8. 4 plus 4 is 8. 5 plus 3 is 8. 6 plus 2 is 8. So, we get these 5 elements as a sum as 8. Therefore, n of b is 5. P of b is equal to n of b by n of s. That is 5 by 36. A intersection b. The common element between a and b are 2, 6, 4, 4 and 6, 2. That is, here 2, 6, 4, 4 and 6, 2 are the three common elements that come under P of A and P of B. 2, 6, 4, 4, 6, 2. 2, 6, 4, 4, 6, 2. These are the common elements. N of A intersection B is equal to 3. P of A intersection B is equal to N of A intersection B by N of S. 3 by 36. P of A union B is equal to P of A plus P of B minus P of A intersection B. 18 by 36 plus 5 by 36 minus 3 by 36. Adding both, we get 20 by 36. When you strike out this using 4 table, we get 5 by 9. Question number 7. From a well shuffled pack of 52 cards, a card is drawn at random. Find the probability of being either a king, either a red king or a black queen. Solution. Sum number 7. N of s is equal to 52. There are 52 cards. So, total number of cards N of s is 52. Let A denote red king. In red card, there are 26 red cards. Out of that, king card are 2. So, N of A is equal to 2. Probability of A is P of A is equal to N of A by N of S, that is 2 by 52. Let B denote black queen. There are 26 black cards. Out of that, there are 2 queen cards. So, N of B is equal to 2. N of B is 2. Therefore, P of B is equal to N of B by N of S, that is 2 by 52. Here, A and B are mutually exclusive events. The intersection part, that is P of A intersection B is equal to 0. Mutually exclusive means A intersection B is 0. That is P of A union B is equal to P of A plus P of B. 2 by 52 plus 2 by 52 is equal to 2 plus 2, 4 by 52. When you strike using 4 table, it is 1 by 13. Sum number 8. A box contains cards numbered 3, 5, 7, 9 up to 35, 37. A card is drawn at random from the box. Find the probability that the drawn card have either multiples of 7 or a prime number. S is equal to 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35 and 37. Here N of S is equal to 18. Let A denote a multiple of 7. Multiple of 7, 7, 21, 35, because here there is 7 here, 21 and 35. So, N of A is 3. P of A is equal to N of A by N of S. That is 3 by N of S is 18. 3 by 18. Let B denote a prime number. B is equal to 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. These are the prime numbers that occur in the sample space S. N of B is equal to 11. P of B is equal to N of B by N of S. 11 by 18. Here, A intersection B. Common element between A and B. 7 is common. In A also 7 and B also 7. So, A intersection B is 1. Probability of A intersection B is 1 by 18. P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A, we know the value 3 by 18 plus 11 by 18 minus 1 by 18. 3 plus 11 is 14. 14 minus 1 is 13 by 18. Sum number 9. 3 unbiased coins are tossed once. Find the probability of getting at most 2 tails or at least 2 heads. Here in this question, we have already come across that 2 tails or at least 2 heads. The word or comes. This means we have to find A union B. In the previous sum, here we have or. Here also we have found A union B. In the previous sum also there is or. So that means we have to find A union B. See here, in each and every sum, whenever or comes, that shows that we have to find A union B. Here 3 unbiased coins are tossed. So that unbiased means unrelated. So S sample space we write S is equal to HHH, HHT, HTH, THH, HTT, THT, TTH, TTT. So we get sample space N of S is equal to 8. Let A denote at most 2 tails. At most 2 tails means to the maximum there can be 2 tails. Minimum there can be 1 or there may not be any tail. So maximum there should be 2 tail. There should not be more than 2. More than 2 இருக்கக்கூடாது. அதாவது 3 tails எல்லாம் இருக்கக்கூடாது. 2 இருக்கலாம், 2, 1 இல்லை இல்லாமலேயும் இருக்கலாம். So we write A is equal to HHT, HTH, THH, HTT, THT, TTH, HHH. There is no tail at all. We can take this. So N of A is equal to 7. P of A is equal to N of A by N of S. That is equal to 7 by 8. So at most 2 tail means to the maximum there can be 2 tails. Minimum 1 or there cannot be any tail, but there should not be 3 tails. Let B denote at least 2 heads. That means at least 2 head means to the minimum there should be 2 heads. Maximum there can be many more. So we select B is equal to at least 2 head. Minimum there should be 2 heads. So HHH, HHT, HTH, THH. There are 2 heads in each and in the maximum there can be many. So HHH we have selected. At least 2 head means below 2 head there should not be 1 and all. That is minimum 2 ஹெட்டுக்கு கம்மியாக இருக்கக்கூடாது. 2 இருக்கலாம், 2க்கு மேலேயும் இருக்கலாம். N of B is equal to 4. P of B is equal to N of B by N of S is equal to 4 by 8. A intersection B. The common element between A and B are HHH, HHT, HTH and THH. So these elements are common in B. And in A, these are the common elements in both A and B. A intersection B, these 4 elements are common in both A and B. N of A intersection B is 4. P of A intersection B is 4 by 8. We write the formula P of A union B. P of A union B is equal to P of A plus P of B minus P of A intersection B. We substitute the values. These 2 values get cancelled. So we get 7 by 8. P of A union B is 7 by 8. Sum number 10. The probability that a person will get an electrification contract is 3 by 5 and a probability that he will not get plumbing contract is 5 by 8. The probability of getting at least one contract is 5 by 7. What is the probability that he will get both? Solution. Let A denote the electrification contract. Let B denote the plumbing contract. Given P of A is 3 by 5. Getting electrification contract is 3 by 5. Not getting plumbing contract is 5 by 8. P of A union B is given as 5 by 7. We have to find P of B. That is P of B is equal to P of B is equal to 1 minus P of B dash or B bar. So we have written here P of B is equal to 1 minus 5 by 8. So it is 8 minus 5 by 8 is 3 by 8. If A union B is equal to P of A plus P of B minus P of A intersection B. Substitute the value 5 by 7 is equal to 3 by 5 plus 3 by 8 minus P of A intersection B. Bring this side. P of A intersection B is equal to 3 by 5, 3 by 8 plus value will become minus 5 by 7. So taking LCM for all the three we get 280. So 5 into number is 2 into 280. Since there is 5 in the denominator, so except 5, we have to multiply the remaining elements, that is 7 into 2 into 2 into 2. So 7 8s are 56. So 5 into 56. So multiply here also by 56. So we get 168. The same way 8 into, hide the 8, 2 2s are 4, 4 2s are 8, hide this. The balance is 5 7s are 35. So multiply by 35. We get 105. The same way hide 7. So balance remaining element is 5 and 8. 5 8s are 40. So multiply by 40. So 5 into 40 is 200. Add both and subtract, we get 73 by 280. Sum number 11. In a town of 8,000 people, 1,300 are over 50 years and 3,000 are females. It is known that 30% of the females are over 50 years. What is the probability that a chosen individual from the town is either a female or over 50 years? Let A denote female, let B denote over 50 years. Given that n of S is 8,000, total number of strength, that is n of A is 3,000, 3,000 is nothing but female. N of B is 1,300, this denotes over 50 years. Here n of A intersection B is equal to 30 by 100 into 3,000, that is 30% of 3,000, that is nothing but 900. 900 are nothing but 30% of female over 50 years. P of A is equal to 3,000 by 8,000, that is n of A by n of S, 3,000 by 8,000. P of B is also n of B by n of S, that is 1,300 by 8,000. Probability of A intersection B is 900 out of 8,000. Probability of either a female or over 50 years, either a female or over 50 years is P of A union B is equal to P of A plus P of B minus P of A intersection B. So 3,000 plus 1,300 minus 900 by 8,000. Adding both, 4,300 minus 900 is 3,400 by 8,000. Striking out the zeros, we get 34 by 80. Again, when you strike out using 2 table, it is 17 by 40. Therefore, the probability chosen individual, a female or over 50 years is 17 by 40. A coin is tossed thrice. Find the probability of getting exactly 2 heads or at least 1 tail or 2 consecutive heads. Exactly 2 heads, that means there should be exactly 2 head. கரெக்டாக 2 ஹெட் இருக்கணும். ஆர் அட்லீஸ்ட் 1 டெய்ல், குறைஞ்சது ஒரு டெய்லாவது இருக்கணும். மேக்ஸிமம் எவ்வளோ வேணாலும் இருக்கலாம், குறைஞ்சது மினிமம் தேர் ஷுட் பி 1 டெய்ல். ஆர் 2 consecutive heads, that means 2 ஹெட் தொடர்ச்சியாக இருக்கணும். consecutive means continuously there should be 2 heads. Solution: S is equal to HHH, HHT, HTH, THH, TTH, THT, HTT, TTT. N of S is equal to 8. There are 8 elements in this. Let A denote exactly 2 heads. Exactly 2 heads means there should be only 2 head. A is equal to HHT, HTH, THH. There are 2 heads in each. So N of A is equal to 3. P of A is equal to N of A by N of S, 3 by 8. Let B denote at least one tail. That means there should be minimum one tail, maximum there can be many more. So B is equal to HHT. Minimum there should be one, maximum எவ்வளவு வேணாலும் இருக்கலாம். அதாவது HHT, HTH, THH, TTH, THT, HTT, TTT. Here, except triple H, HHH, except that we can take the remaining elements. There are 7 elements. So, n of B is equal to 7. P of B is equal to n of B by n of S is equal to 7 by 8. Let C denote consecutively 2 heads. That means consecutively means continuously there should be 2 heads. C is equal to HHH, HHT, THH. Here we get continuously 2 heads. So n of C is equal to 3. P of C is equal to n of C by n of S. 3 by 8. A intersection B. Common element between A and B. Here in A, these 3 elements are common in A and also in B. That is HHT, HTH, THH. These are the 3 elements common. So we write A intersection B is equal to HHT, HTH, THH. N of A intersection B is equal to 3. P of A intersection B is equal to 3 by 8. Here B intersection in B, HHT and THH. C, HHT and THH. These are the 2 elements common in B and C. That is B intersection C is HHT, THH. So n of B intersection C is 2. P of B intersection C is equal to 2 by 8. C intersection A. In C, HHT, THH. In A, HHT, THH. These 2 are common. So we write C intersection A is equal to HHT, THH. That is n of C intersection A is equal to 2. P of C intersection A is equal to 2 by 8. At last, A intersection B intersection C. Common in all the 3. We get HHT, THH. N of A intersection B intersection C is 2. P of A intersection B intersection C is 2 by 8. P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. That is 3 by 8 plus 7 by 8 plus 3 by 8 minus 3 by 8 minus 2 by 8 minus 2 by 8 plus 2 by 8. Here positive 2 by 8 and negative, these 2 get cancelled. Plus 3 by 8 and minus 3 by 8 get cancelled. So balance 3 plus 7 is 10. 10 minus 2 is 8. 8 by 8 is equal to 1. Sum number 13. If A, B, C are any 3 even such that probability of B is twice as that of the probability of A and probability of C is thrice as that of probability of A, and if P of A intersection B is 1 by 6, P of B intersection C is 1 by 4, P of A intersection C is 1 by 8, P of A union B union C is equal to 9 by 10. Probability of A intersection B intersection C is equal to 1 by 15. Then find P of A, P of B, P of C. Solution given probability of B is twice that of probability of A, probability of C is thrice that of probability of A, and they have given P of A intersection B 1 by 6, B intersection C 1 by 4, A intersection C 1 by 8, A union B union C is equal to 9 by 10, A intersection B intersection C is 1 by 15. We find P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. We substitute the values. 9 by 10 is equal to P of A plus twice P of A plus thrice P of A minus 1 by 6 minus 1 by 4 minus 1 by 8 plus 1 by 15. Here P of A we write as it is. P of B is given that P of B is twice P of A. That's why we substitute here. P of C is thrice P of A. So we write here. When you add everything, so this is nothing but 1. 1 plus 2 plus 3 is 6 P of A is P of A minus 1 by 6 minus 1 by 4 minus 1 by 8 plus 1 by 15. So now we keep this as it is. P of A we have kept as it is. Bring these values this side. So taking LCM we get 120. In the numerator we get 108 plus 20 plus 30 plus 15 minus 8. So when you add everything and subtract we get 165 by 120 is equal to 6 P of A. So 165 by 120 is equal to 6 P of A. Bring this 6 down. P of A is equal to 165 by, we have brought 6 down, so when you multiply we get 720. When you strike out this we get 11 by 48. We strike out using 15 table. P of A is equal to 11 by 48. P of B is twice P of A, no. So 2 into 11 by 48. That is nothing but, we strike here using 2 table, 11 by 24. P of C is equal to thrice P of A is equal to 3 into 11 by 48. Using 3 table when you strike we get 11 by 16. 14. In a class of 35 students are numbered from 1 to 35. The ratio of boys to girls is 4:3. The roll numbers of students being with boys and beginning with boys and ending with girls. Find the probability that a student selected is either a boy with prime roll number or a girl with composite roll numbers or an even roll number. Given n of s is equal to 35, the ratio of boys and girls is 4:3. Number of boys is equal to 4 by 7 into 35, that is 20. Here when you strike using 7 table, 5 times 5 fours are 20. Number of girls 3 by 7 of 35, we get 15. Here the total ratio is 4 plus 3 is equal to 7. That's why we use 7 here. Let A denote boys with prime roll number. That is A is equal to prime numbers. Prime roll numbers are 2, 3, 5, 7, 11, 13, 19. There are only 20 boys. So n of A is 7. P of A is n of A by n of S, 7 by 35. Let B denote a girl with composite roll number. Other than prime numbers are called composite numbers. So therefore, B is equal to 21, 22, 24, 25, 26, 27, 28, 30, 32, 33, 34, 35. Other than prime number from 20 to 35, here the composite numbers are given. N of B is equal to 12. Therefore, P of B is equal to n of B by n of S, that is 12 by 25. Let C denote even roll number, that is C is equal to even roll numbers up to 35, that are even numbers, that is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. N of C is equal to 17. P of C is equal to n of C by n of S, 17 by 35. A intersection B is empty set. There is nothing intersection common. That is n of A intersection B is 0. P of A intersection B is also 0. B intersection C. Here in B intersection C we get 22, 24, 26, 28, 30, 32, 34. These are the common elements among B and C. That is 22, 24, 26, 28, 30, 32, 34. It is common in both B and C. So we write n of B intersection C is 7. P of B intersection C is 7 by 35. C intersection A is 2 common. So n of C intersection A is only 1. That is P of C intersection A is 1 by 35. P of A intersection B intersection C, common in all the three, A, B, C. Common in all the three is nothing. So it is 0. Therefore, P of A union B union C is equal to P of A, P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. So we substitute the values here plus 7 by 35 minus 7 by 35 get cancelled. Here adding both denominators are same, so 12 plus 17 is 29, minus 1 is 28 by 35. When you strike out using the table 7, we get 7 4s are 28, 7 5s are 35, that is 4 by 5. Exercise 8.5, probability 1 mark. Sum number 9. Which of the following is incorrect? P of A greater than 1, 0 less than or equal to P of A less than or equal to 1, P of phi is equal to 0, P of A plus P of A bar is equal to 1. Here in this, P of A greater than 1 is incorrect. Sum number 10. The probability a red marble selected at random from a jar containing P red, Q blue and R green marble is Q by P plus Q plus R, P by P plus Q plus R, P plus Q by P plus Q plus R, P plus R by P plus Q plus R. Sample space S is equal to P plus Q plus R. N of S is equal to P plus Q plus R. Probability of selecting red ball. Here red ball is only P. P is red ball. So P by P plus Q plus R. Sum number 11. A page is selected at random from a book. The probability that the digit at unit place of the page number chosen is less than 7 is 3 by 10, 7 by 10, 3 by 9, 7 by 9. Probability of digit at unit place of the page is less than 7, that is 7 by 10. N of S is total number of pages 10. So A is less than 7 means 0, 1, 2, 3, 4, 5, 6. So there are 7. So N of A is 7. So the answer is 7 by 10. Sum number 12. The probability of getting a job for a person is x by 3. If the probability of not getting the job is 2 by 3, then find the value of x. A 2, B is 1, C is 3 and D is 1.5. Given P of A is equal to x by 3, P of A bar is equal to 2 by 3. We know that P of A plus P of A bar is equal to 1. That is x by 3 plus 2 by 3 is equal to 1. X denominators are same, so x plus 2, add the numerator, x plus 2 by 3 is equal to 1, cross here, x plus 2 is equal to 3, x is equal to 3 minus 2, x is equal to 3 minus 2 is 1. Sum number 13. Kamalam went to play a lucky draw contest. 135 tickets of the lucky draw were sold. If the probability of Kamalam's winning is 1 by 9, then the number of tickets bought by Kamalam is 5, 10, 15, 20. Given N of S is equal to 135. N of A is x. P of A is equal to N of A by N of S, that is x by 135 is equal to 1 by 9. They have given already. So from this x we have to find. Cross here 135 by 9. 135 when you strike out using 9 table we get 15. 14th sum. If a letter is chosen at random from the English alphabet A, B, etc. up to Z, then the probability that the letter chosen precedes X is 12 by 13, 1 by 13, 23 by 26, 3 by 26. Solution. N of S is equal to 26, N of A is equal to 23. So already 26 minus 3, we get 23. Therefore, P of A is equal to N of A by N of S is 23 by 26. Presiding X means we have 3 elements after that, X, Y, Z. So we subtract this and we get 23 by 26. Sum number 15. A purse contains 10 notes of 2000, 15 notes of 500 and 25 notes of 200. One note is drawn at random. What is the probability that the note is either a 500 note or 200 note? 1 by 5, 3 by 10, 2 by 3, 4 by 5. Solution. N of S is equal to 50. There are totally 50 notes. N of A is 10, N of B is 15, N of C is 25. Here they are asking about P of B union C. P of B plus P of C. That is, B and C are mutually exclusive even. So we write this like this. So 15 by 50 plus 25 by 50. Adding both we get 40 by 50, that is 4 by 5. Here B denotes 500 note and C denotes 200 notes. They are asking about 500 note or 200 note. So 500 or 200 means B union C we have to find. So that's why we get 4 by 5.
I hope you have understood everything. Note down everything in your classwork note. Note down the assignment. Exercise 8.3, sum number 9. Exercise 8.4, 6th and 12th sum. Do the assignment. Send us a single PDF. Don't send multiple images. Dear students, this is the easiest chapter, probability. From this you can score more marks. Concentrate well. Do all the sums. Work out and see. Revise all the sums. Thank you, students.